All right, so this next graph right here is a little different than our first. So if you'll remember on the first one, it was just the log of base 3 of x. Okay, this time I have some base here, mine is 1/3 this time, but I'm going to add 1. When I start this, so I first of all am just going to graph that. We call it kind of the parent function. It changes depending on what your base is, but I'm just going to graph this picture first. This is a transformation. We've talked about these before. We'll graph that at the very end. So we're just going to graph this. Remember, there's only 2 points that you need to know. You always have 1, 0. That's always a point on your graph. And then your base, or in this case, it's that 1/3, goes to 1. Okay, so those are always points. You just need to memorize that. I'll write them up here again. 1, 0, and whatever your base is maps to 1 right there. So those are always 2 points. So when I graph those, here's my 1, 0. This time my 1/3, so when I go over 1/3 for x, it goes up. Now this is a reflection. Notice right here. So normally our base went from a smaller point here to a bigger point. These are going to go down. This is what we call, when you have a fraction as your base, it reflects it over that y-axis right there. So it still is never going to cross 0. Your asymptote right now is at that x equals 0. So this graph, though, will get really close to that 0 when you're going up, and then it will come down over here when we're going down. Okay, now you're going to go back and say, okay, what does this plus 1 do? So basically what that does is that takes all of your y values. Notice it's not grouped in with the x. So this is a vertical shift. If it was a horizontal shift, it would be with the x. So in parentheses with the x. But anything just tacked on at the end goes up or down. So that just moves all of your points up 1. So you're just going to go back and grab those 2 points that you had before, my 2 green points right there. You're going to just move them up 1 right there. And then I'm going to erase this line, all those lines right there. I know it's not as easy for you to do it on your paper, but then we will draw these lines back in. Again, the asymptote didn't change, so it's going to get, it's going to get really close to this 0 right there as I'm going up, and then it will head off over this direction. Okay, so since my asymptote did not change, my domain's the same as before. That means my x values just go from 0 clear out to infinity. Okay, range is always going to be negative infinity to infinity. That one will be a given on all of them. We're not going to do this x-intercept, especially on ones like this. This one, it would have been okay. We're not going to do it on these. The asymptote, again, we didn't move that asymptote. We didn't move it left or right. So it still is just going to be x is equal to 0. However, this time, as we read our picture, remember we read left to right. So as we read from the left to right, notice how our y values are decreasing. So they are not increasing ever. They're only decreasing. Just use that domain again. So they're decreasing from 0 to infinity right there. And then end behavior. Let's go ahead and write end behavior. So again, use your 2 ends of the domain. So on the left end of your domain is 0 here. And your y, or I guess I should probably write f of x because you guys are now juniors. So this f of x right here, on the left, see how those values, your y values, your f of x values are going up to positive infinity. And then on the other side, as we are going down to negative, the y's are going down, but the x's are going to positive infinity. This is my positive x's over here. So as I go to positive infinity, my y's, or my f of x's, are going down to negative infinity right there. All right, let's try another one in this video. This one has a horizontal shift. So again, before I graph this, I'll notice 2 things. Notice that there's a negative right there, and then notice that there's a subtract 2. Before we do that, I'm going to graph the parent function, just a really basic function. I'm going to graph log base 2 of x. That's all I'm going to graph. And I just need 2 points, remember? So all you're doing is grabbing the 2 points. You're going to whoops, froze here for a minute. Okay, so we're going to grab the 1, 0, that's always our point, and then our base, or our 2, 1. Okay, so graph those 1, 0, 2, 1, and our picture would normally look like this with that asymptote right here. Okay, but now we've got to make a few transformations. So remember, I know we haven't graphed for a while. We skipped graphing in our last unit. Well, we didn't. We graphed some polynomials. But this negative right there reflects my picture over the x-axis. So basically what it does is it flips it upside down. So this end is now going to be up here. This is on the x-axis. It's going to stay, but this one, since it was 1 away, it's going to go 1 away down here. And your picture is going to really look like this. Okay, so we just flipped that. Let's erase the red so I don't mess you up here. Right there, but my asymptote didn't move with the reflection. However, we have one more transformation. So we've put that negative back in. Now what we've graphed is the negative log base 2 of x. However, they want us to graph the negative log base 2 of x minus 2. Since that's grouped, it's in parentheses with the x, that means it's a horizontal shift. It goes left and right. Please remember, though, that negative really moves at the positive direction. Anything that's horizontal goes the opposite way that your gut would tell you to go. So this is just going to take those 2 points that we have and shift them to the right too. So pick this one up, and it goes over. Whoops, I can't count evidently. Let's try that again. So this point, let's erase that and then try again. Okay, my goodness. Okay, so this point goes over 1, 2, and it goes right there. Okay, not only do those 2 points get moved over 2, but this nice, lovely asymptote that was right here, let's draw it red, it was red before, also shifts over 2. So that means that this is the line, that 2 is the line that it cannot cross, not 0 anymore. So when you complete your picture, when you draw this picture right here, you're going to use those 2 points, but you're going to use that new asymptote right there to draw this. And then again, I'm going to erase my orange one. This is good picture. It just wasn't translated. It was before we moved it over 2. But this is what my graph now looks like, right? Like this. Now this changed my domain. When I moved my asymptote over 2, I'm not going to get any numbers that are smaller than 2. So my domain's just going to go from 2 all the way up here to positive infinity. My range didn't change. This range will always be the same forever. It's negative infinity to infinity in a logarithmic function. X-intercept, we're not going to do this unit. My asymptote, that's what I changed. That horizontal shift changed it. It moved it over 2. So it's now positive 2. Remember, the negative goes the positive direction. If it were a plus 2, it would have moved it back or to negative 2. When I read this, notice right here, as I read left to right, my y values are decreasing as I follow that picture. They're decreasing with that negative. It made it go upside. So it's not increasing, but it's decreasing in my domain from 2 to infinity right there. And we're also going to use that 2 and that infinity for our end behavior. So we're going to look at both of those ends right there. And we're going to say, well, as x is going to 2, that's right here. Here's my 2. My y's, or my f of x's, are going to infinity. As my x goes to positive infinity, my y's, or my f of x's, are going slightly, but they are still going down. So it's going to go to negative infinity. All right, we'll add a few more of these transformations in our next video.